Good morning, online students. Here is the topic for the first week. So how this is going to work is I'm going to have videos set up for you guys in all the different sections and topics that we're going to cover, and I'm going to break them up a little bit. So this first week that we have is kind of our introduction to DC. We're going to talk about the basics of electronics, where it comes from, kind of all the nitty-gritty things that we need to. With that, I'm going to break these up again, like I said, into various numbers of sections, and 7, 8, 9. I'm going to have about 9 sections for this first week. So what we'll do is we're going to cover the different math topics first, and then we'll get into the electronics theory. And primarily that's how these are going to flow, is we're going to have the math done first, and then the theory, the electronics theory, in the second half of the week, basically, as we get going. So what this is going to be, and hopefully this is a review for a lot of you, but this is going to be the different aspects of math that we are going to use and apply in electronics. And how the main idea of this is set up is what we cover this week is going to be the stuff that we discuss and we use the following week. So it'll always be a week ahead on the activities that we're doing and the math problems and things like that, and how we can actually apply it. So be aware with that. This first week, it's going to be a little bit kind of a review, just to make sure we are all on the same page with these different aspects. So this first video that we're going to do is going to be based on the concepts of basic math ideas that everybody should kind of know when we are doing this. Struggling to get my tablet to work a little bit. So the things that we're going to cover in this first section is going to be the number line. We're going way far back. We're going to talk about number systems. And at the end of this, we're going to talk specifically about the decimal number system. And that's what we are going to primarily be using. So, first aspect is the number line. The number line is basically a line that goes off in any direction to the positive infinity on the right and the negative infinity on the left. And what this does is this represents every number that we have available to us to use. Right in the middle, we're going to call this point 0. 0 is our midpoint. We can call that our baseline, our 0, our neutral, whatever you want to think about it. That is where we're at. This is our starting point. So everything is going to be based on this idea of how much distance am I away from this 0 point, my reference. Where do I need to go? So on the number line, we can express both positive and negative numbers, as I've kind of indicated here with our positive and negative infinity. So as we move off to the right of our number line, those numbers are going to get more and more positive. So here we would have 1, 2, 3, 4, 5, 6, 7, so forth. Okay, all the way up. On the left-hand side, we are going to have numbers that are smaller than 0. These are our negative numbers. -1, -2, -3, -4, -5, so on and so forth. So as we go on with those, what the idea of these are is this gives us positions and magnitudes relative to that 0 position. I apologize for my computer making noise. My tablet's not wanting to stay connected. So with that being said, we can look at these and we can then assign values. So positive numbers are going to be greater than negative numbers. So when we look at these values and we use the terms greater than or less than, it's in reference to the 0 point. Something is larger if it's greater than the number, if it's farther away. We can also look at the magnitudes and say they are magnitudely, they're equidistant away from our 0 point. If we have +5 and -5, they're going to be the same magnitude, just one goes in one direction, the other one goes in the other direction. So with that, we also have things and comparisons we can make, such as greater and smaller numbers. Like I said, with these positives and negatives. Positives will always be bigger than negative numbers in our vocabulary and in our thinking. We can also write a series of numbers. We've got negative 5 is going to be less than negative 1, which is less than 20. And I can go with the other direction. 20 is greater than negative 1, which is greater than negative 5. So either way, I can split this through and say negative 5 is also less than negative 20. 20 is also greater than negative 5. And we're going to reference numbers in this manner. Okay, number line, that's it. It's pretty simple. It's about the basics of what we're going to get. Just understanding we've got positive, negative numbers. We could have fractional numbers. We could have decimal numbers, with a 0 and a decimal point, things like that, so on and so forth. And as long as we can understand that, that's going to be what we need to start with. All right, so after we get to that point, we're going to look at different types of number systems that exist. So a number system is simply number system. It's a set of numbers that we use. So set of numbers used. General day-to-day life is what we call base 10 or decimal. The other number systems that we can have base 2, we can have base 8, we can have base 16 are some of the common ones we use. Base 2 we refer to as binary. Base 8 is octal, and base 16 is hexagonal. And basically what this means is this just tells us how many numbers that we use to represent information. In base 10, we have 10 numbers available to us. Those numbers are 0 through 9. And then in our places, we have different values. We've got hundreds, tens, ones, and then we hit our decimal point. And then we go to tenths, hundredths, and thousands. So in our numbering system, based on the place of these values, we can then add in 0 through 9 to represent anything we're after. If we wanted to represent the number 99, we would put 9 in the tenths column and 9 in the ones column. Kind of self-explanatory, hopefully, when we see that. This is the numbering system that we are used to all day, every day. Binary has two numbers to choose from, 0 or 1. In binary, we have a decimal, or we have our values of 1, 2, 4, 8, 16. So each of these places has a different value associated with it. So a 0 or 1 means a 1 in the 1 spot means I have 1. A 1 in the 2 spot means I have 2. 1 in the 4 spot means I have 4. And then we can simply add them together. So if I've got a number that's 1, 1, 1, that is 1 in the 4, 1 in the 2, 1 in the 1, which gives me a total of 7. So I can represent this information, the number 7 that we're used to, into a series of 1s and 0s. Octal gives us 8, so we have 8 numbers to choose from. We've got 0 through 7. The same thing with that, it has its place. The very bit, we have the 1's place, then we have the 8's, then we have the 16's. Sorry, no, not the 16's. We have the 64's and 512's and so on and so forth. So this gets bigger and bigger. So if I have a 7 in the 1 spot, that means I have 7 1's. If I have 7 in the 8th spot, the 80's, so that means I have 7 8's. So that's going to give me 72. And then I have 7 1 over here. So that's going to give me at 79. And this is going to represent 79 in octal. Hexagonal is going to be 16 numbers. We have 0 through 9, but then we also have A through F. So I know letters are not numbers, but in this case we're using them as numbers and defining them as such. So in that case, we would have the same values with this. We would have, if I can find where my pen went, there we go. So we have 1, then we're going to go to 16, and then the next column is going to be 256. Next column is going to be 4096, and so on and so forth. So what happens is I can have up to an F in this value representing ones, and what this is A is a 10, represents the value 10, B is equal to 11, C is equal to 12, D is 13, E is 14, and F is 15. I know it's a lot. We're going to talk about this more when you get more into second semester, but for now, at least is the base idea. So if I have in my system, come over here, and if I put an F in this ones column, that means I have 14 ones. So my number of just F is 14. If I have F in my 16 spot, that means I have 15 16s. So then I can do that math real quick and find out what those values are. And the cool thing about this is with this hexagonal number, this hex number, we can actually encode a lot of information in a very, very small amount. So if I put this F in here, what we're going to get is 4095. So this value here, which is 4 digits, we can represent as a 3-digit hexadecimal number. So it's really good to be able to encode large values in a very small amount of space. And again, like I said, this is what you're going to talk about when we get more into second semester and when you start into programming, things like that. But be aware that these types of systems do exist. The primary one that we are going to use on a day-to-day basis is going to be base 10, which is what we're all familiar with. Counting normally, when you hit the 10, it rolls over into the next place. The other systems work the exact same way. When you roll up to their maximum amount, it's going to end up on the end. All right, so that's our numbering systems. The common ones we use in electronics, like I said, is base 10, base 2, base 8, base 16. Decimal, binary, octal, hexagonal. And the primary one we're going to be using for this class and for most anything that we do is base 10. All right. So getting on with that, we're going to talk a little bit more about this decimal number system and how we can use it. So this decimal number system is just learning how to manipulate values, how to manipulate data, keeping them in that order. So like I said before, in the decimal system, so the decimal number system, we have 10 numbers available. And those numbers is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Oh yeah, before we get too far into it, I want to make a note. If you noticed, my 7 looks a little funky. And that's because when I get writing fast, my 7s can start ending up looking like different numbers. My 2s sometimes can look like 7s. It's a mess. So I put this little line through my 7 to designate it that it is a 7. I also do that, if I can get this thing just to draw it, I also do that with my letter Z's, because again, if I'm writing it fast, my Z can look like a 2. Is that supposed to be a 2? Is it supposed to be a 7? So I put the line through it just so we are aware. Just be aware that's what's going on with it when you see those. I've had to do it for myself to distinguish what values are which. All right, so we got 10 numbers to choose from. So we got 0 through 9. And then we have our values of our places, like I explained earlier. In our whole numbers, so what I have is my ones, my 10 spot, my hundreds, my thousands. Each number of each valid number represents a value of this. So if I have 7,331, that means I have a 7 in the thousands place, which means I have 7,000 added to my total. My first 3 is going to be in the hundreds, which means I have 300 in that spot. My next 3 is in my tens, which means I have 30, and I have a 1 in the ones place, which means I have 1. We add all those together and we get 7331. The same pattern works for the other numbering systems. We just have to understand what those base values are. Okay? And then after that, I also have not just whole numbers, but I have partial numbers. So up here I have partial or fractional or decimal. So again, I have the same numbers available to me, the 0 through the 9, but then what I also get in this aspect is I can relate values that are smaller than 1. I have my tenths, I have my hundredths, thousandths, and so on. So my tenth is going to be 0.1, so how many of those I have? My hundredths is 0.01, my thousandths is 0.001. So again, I can use those. Up here, I had my ones values, my tens, my hundreds, and my thousands. So how many of each of those do I have in there? If I have the number 3.1415, what this number translates to is I have 3 ones, which is 3. I have 1 in my tenths. Oops, I don't need that H there. Tenths. So that means I have 0.1. I've got 4 in my hundredths, which means I have 4 hundredths. I have 1 in my thousandths, so that's going to be 0.001, and I have 5 in my 10 thousandths, which is 0.0005. Then when we add them together, we come back to that. So it makes it pretty easy. So when we're talking about it, we just need to make sure we're understanding what value, what numbering system we're on, and how we want to express that number. All right. Next thing we're going to talk about in this is, come on. Sorry, I'm having problems with my computer system today. So when I have these values, I can convert them back and forth between decimals and fractions, and vice versa. So if I have the number 1.455, that means I've got 1 whole, and I have 455 thousandths, which I can then write as this. Then I need to take that and convert it down into the smallest number. So I need to find what is my common denominator, find out my common values, and reduce everything down. But this is what this means, is I've got 455 thousandths, this is my decimal portion, this is my fractional portion. If I have 3 and 75 over 100, if I want to translate that from my fractional value into a decimal value, means I have 3 and I have 75 hundredths, 7 tenths, and 5 of the hundredths. And we can go back and forth from that. I also have, if I have 8 ninths, that's going to give me a decimal of 0.8888 repeating. Okay. Keeping in mind with that, these are just the straight conversions. We're going to include the repeating, that kind of stuff. All right, so going back and forth between these values is going to be the distinction of how I can work with these values. How do I work with them? And again, these come into their place values. What is this place? What is this place? What is this place? What is this place? And if I can go back and forth and maintain them, I can then say I have my equals, my equivalencies. And that's the whole idea of these conversions, is I want a decimal equivalent and I want a fractional equivalent. And I want them to mean and be the exact same thing. If they're not, then I have some problems. Also, we want to have the ability to go back and forth because there's times where we're going to want decimal numbers. We're going to want this 0.8888. There's going to be other times that we want fractions like this 455 over 1,000 because maybe on later down the line we have something that's going to get rid of that number for us. And then we don't have to deal with it anymore. It happens quite often in electronics, and it's something we should look forward to. So that's it for this first video. We're just talking about the number line, basically what do we have available, the types of number systems we have, which again, the common ones that we use here is decimal, binary, octal, and hexadecimal. And then we talked about positioning with these values in the decimal system. How do I convert the numbers back and forth? What do each of the places mean? And all that kind of stuff. The decimal system, again, 10 numbers, 0 through 9, and our place values is the 1, 10, hundreds, thousands. Going on the other side, it's the tenths, hundreds, thousands, and so on and so forth. Making sure we have an understanding of this. You should already know this information. This should be very, very basic. But again, we're just going to cover everything to make sure that everybody's on the same page and on the same track.